Good morning or good afternoon, class. I'm not sure when you'll be seeing this. We're going to try something a little bit different since schools are going to be out for not only the rest of March, but also through May. I'm going to try to post some YouTube videos with some content from class that we would normally do together. Some of the content that's more difficult, I'll try to walk you through how to do those things so you can get a better understanding of how biology works. Things like transcription translation, which makes our proteins. That can be very difficult to understand from reading from a textbook. Sometimes you need to be walked through the process to fully understand how that process works. Or the process of meiosis, which is very similar to mitosis, but has extra steps involved, and the product is very different, although it uses a lot of the same terminology as mitosis. But before we get into the content that's related to what we normally cover in class, I'd like to go over some current events. Right now, there is some misunderstandings and confusion about what's going on with the pandemic. For starters, the name. There's coronavirus that is used, and then there's also CoViD-19. Let me start with COVID-19. I got a whiteboard. So, COVID-19 is just an acronym. 19, starting at the end, because that's going to be a little bit easier, refers to 2019. That was the year that the virus was discovered by scientists and medical professionals in China from a town in not too big, but not too small, a little bit bigger than Sumter. And the 19 there just refers to the year that it was identified. The D in COVID stands for disease. The VI, vid, the VI stands for virus, and CO is short for corona. So coronavirus disease 2019. Corona is not referring to the beer, but it goes back to the Greek for corona, meaning a crown. The virus, I kind of drew it a little bit here in the middle, has little bumps on the outside of it. Those little bumps are caused by proteins, and they look like little tiny bumps that you see on a crown, the little parts that stick up. Those bumps on the virus are kind of like IDs, or sometimes like a key. So inside your body, you're made of trillions of cells, and each one of those cells has these little tiny bumps of protein on them, and they work as identification for your body to know whether or not those cells belong, or if they are bacterial cells, or if they are fungal cells that should be destroyed. Same thing here on the virus. They have little bumpy proteins that stick outside of the phospholipid bilayer, cell membrane, and they allow the virus to be identified. Unfortunately, it takes a while for your body to learn, once infected by the virus, to recognize these little bumpy proteins as something dangerous. They mimic our actual proteins from our cells. In fact, most of them are stolen from our cells. Inside the virus, and you might remember that viruses are not living. Most biologists don't consider them living because they cannot reproduce by themselves. They cannot grow and multiply by themselves. They cannot respond to the environment like most living things do. They do not adapt. They do not evolve. They do not need energy on their own until they get inside of a host. So the consensus is large that they are not considered living things. But they have that phospholipid bilayer on the outside, they have the proteins, and they have inside, not a nucleus, but a nucleic acid. Some viruses have DNA. For example, HIV/AIDS is a DNA virus. Your common flu, influenza, is a DNA virus. But for some viruses, they don't have DNA. They just have RNA. COVID-19, or coronavirus, is an RNA virus. We are going to be moving into a unit where we're going to look at transcription translation. And that RNA inside the virus can insert its code, its gene, into your ribosomes. Your ribosomes make proteins, hopefully you haven't forgotten that. And when it inserts its RNA into your ribosomes, it's going to start making new proteins to make more viruses. Also, inside of the capsule of the virus are little tiny enzymes. I drew there as blue. Those blue enzymes can assist the virus in manipulating the cell to read and make more viruses. So, what can we do? Right now, we're trying to slow the spread of the virus. You probably have heard of flatten the curve, and I kind of drew it over here with red, blue, and black. Flatten the curve refers to trying to slow the spread of the virus. The virus, we don't have a treatment for right now. You may have heard in the news or seen online that the WHO, World Health Organization, which we covered with smallpox, is working on trying to fight the virus, but there is no vaccination yet. They're working as fast as they can, and once there's one available and it's been tested and shows that it affects the person without causing too much harm but stops the virus, then of course they're going to put it on the market and they're going to try to start vaccinating people. In the meantime, we need to flatten the curve. Here in red is what we fear, what we don't want to cause. If we continue with our interactions, going to school, going to work as normal, and interacting with one another, then there's going to be a spike of people getting sick until it hits a critical point where there's enough of the population that's sick that the virus just can't spread much anymore because it hasn't hit any hosts that it hasn't already encountered, and it starts to drop off and go down. The problem with this is it will overwhelm our hospitals, our clinics, our doctors and our nurses that are trying to treat the illness. There's not enough doctors and nurses to go around. There's not enough ventilators to go around. There's not enough supplies. So we don't want too many of the population get sick at once. Instead, what we want to do is flatten the curve there in blue. Flatten the curve will stretch out the virus and at least its effects, and hope that people will not get too sick all at once. So then we don't overwhelm the doctors and nurses, the hospitals and clinics, and don't exhaust all of our supplies too quickly. This, of course, will mean the virus will last longer, but that will also hopefully buy us time for a vaccine. If we get a vaccine at some point, then of course that curve should drop dramatically after the vaccine is released. Or if we do enough to slow it down, then it will start to curve down. So besides trying to flatten the curve, what else can we do? You've probably seen on online and on YouTube and maybe even on Instagram, social distancing. So what we're trying to do is we're trying to space people out, not have crowds, not have concerts, not have wedding events, not have family reunions, not have schools crowding students all together. We're trying to space people out because the virus needs to jump from host to host. But if we're all spread out, then it can't jump from host to host too easily. It is a respiratory virus, so it goes from one person's lungs through the air into another person's, or it can leave a person and get on a surface. You touch that surface, and then you rub your mouth or your nose, and you can breathe it in. If we space ourselves enough, then hopefully the virus, if it gets landed on a surface, it will sit there long enough to die or fall apart. Then it won't be a hazard to another person that comes in contact with that surface. I have below there, washing your hands. You probably heard on the news and online, you need to wash your hands. So your hands are full of a bunch of different pores. Those pores, if you like pet a dog or a cat, you can feel the oil in your skin, or if you touch something dusty or dirty, it feels gritty on your hands. That's because those pores, those low spots in your hands, can pick up little tiny particles and hold on to them. That's what leaves that oily feeling on your hands or that gritty feeling. What we want to do is we want to recognize that our hands can hold a lot of different materials, including viruses and bacteria and spores from fungus and other things. So since we have a pandemic with the virus right now, we want to wash our hands thoroughly using soap, warm water, not scalding hot, don't burn yourself, but really warm water, and use enough soap and create a good lather and wash your hands thoroughly. You probably learned in kindergarten, sing the happy birthday song all the way through. Sometimes they suggest do it twice. There's some other songs that you could sing in your head. You don't have to sing out loud, but you want to make sure that you give the soap enough opportunity to pull those viruses out from the grooves inside your fingers and your hands along the skin. Also, good news is that the outside of the virus is made up of a phospholipid bilayer, and soap can attach itself to the phospholipid bilayer and start pulling on it. So that friction of you washing your hands can start to break down the membrane of the virus. Also can do that for bacteria, can do that for spores from fungus. So washing your hands, yes, could be good for this virus, but for other illnesses as well. There's other things you can do. You can do the social spacing. You could not crowd yourself, not be close to others right now that you don't know if they're sick. You could also try to protect your airways by, some people are wearing masks when they're in hospitals or clinics. If you're not in the area with infected people, probably wouldn't worry about that. Also, just practicing good hygiene can be very helpful. So, what are some of the effects? Right now, I've seen in the news where it's a little bit debatable as to some of the earliest signs. But if you have a fever, that's one of the earlier signs that you might have an infection. Otherwise, if you're sneezing, if you have a dry throat, that drinking some water or something else just doesn't seem to get rid of it, that might be an early sign as well. Don't worry, it doesn't just miraculously appear. It only gets to its next host from one person to another, or from a person to a surface to its new host. So why are we staying home? We're staying home to avoid the transmission from one person to the next. Don't worry, there has been other pandemics in the past, and we've survived. There has been the Spanish flu that killed a lot of people because of World War I when it was being spread. And there wasn't a whole lot of focus on fighting that virus right then and there. The focus was on winning the world war. Right now, we are across the world all fighting this virus together. We're not preoccupied with much else. So the death toll should be much lower. We are trying as fast as we can to prevent the spread of the virus and to work towards a vaccine. We've dealt with pandemics before in the past as a human species. This is not too new, it's just new for our lifetime. We haven't lived through one, but our great-grandparents and those that came before did have to encounter one, and we made it. The next video that I will release will not be on COVID-19 unless there's some new news comes out that might be useful and need to be explained. But my plan is the next video will be on our notes for cancer, how cancer develops, and things that can encourage a risk for cancer, leading to a higher probability of developing cancer. So stay tuned for that. I may not release that until tomorrow or a couple of days. I'm still learning this YouTube process. I hope you're doing well, and I hope you are not having technical difficulties right now. I guess if you're seeing this video, you don't have technical difficulties. I'll find out from those that I can't see the video that they're having issues. Stay well, stay safe, and I hope to hear from y'all this week or the coming weeks.